So in this video, we're going to go through the momentum transformations. Okay, so coming back to here, remember we had to redefine momentum so that it was now conserved. It's a conserved quantity. And that also meant we had to redo the energy right here so that now this is a conserved quantity. But Frank and Mary will not agree on the momentum. They'll both say they're conserved, but momentum in one frame will not be equal to the momentum in another. And that's what I wanted to go through here today is what is the transformations from momentum in, say, Frank's frame and energy in Frank's frame to momentum in Mary's frame. So just to remind you, from right here, I'll just rewrite this one right here. The energy, total energy in Frank's frame, let's say, is mc squared all over the square root of 1 minus u squared over c squared. But Mary would say, no, E prime, I get a different energy. That's equal to m. M is the same to everyone. C is the same to everyone. All over the square root of 1 minus u prime squared over c squared. Likewise, for momentum in the x, this would be mux all over the square root of 1 minus the total speed squared over c squared. Px over here, prime would be mux prime all over the square root of 1 minus u prime squared over c squared. And we might as well look at the y. Y is muy all over the square root of 1 minus u squared over c squared. And py prime was muy prime all over the square root of 1 minus u prime squared over c squared. Okay, we want to know how do these transform into these right here. Well, it looks like, at least for this, the only thing that's really transforming is this 1 over the square root right here. So we really should just see is how does this transform back to this? So let's just look at that. Let's just look at that term. Forget about the mc squared because we seem to have a lot of these all over here. So what if we just say 1 over the square root of 1 minus u prime squared over c squared. And let's just see, take away all the primes and see what it becomes. So that is equal to 1 all over the square root of 1 minus u prime squared is ux prime squared over c squared minus uy prime squared over c squared. Okay, and now I really just have to plug in what the ux prime is and uy prime is and square them and put them all. But I think so I don't bite off such a big piece, I'm just going to take let's look at this piece right there. There it is right there. And I'm just going to work with that first, and then I'll expand upon that. So this is equal to 1 minus ux prime squared all over c squared, which is 1 minus, now ux prime is right here. So we're going to square that. ux minus v squared all over, I still have the c squared there, and then we have the 1 minus uxv over c squared. Okay, then I think what we'll do is, I need a common denominator right here. So before I do that, I think I'll move the c squared up with this term. So we end up with 1 minus, this is ux minus v squared divided by c squared. So I just move that over to here. Divided by 1 minus uxv all over c squared. And I think that's squared too. Squared. Okay, now we'll get a common denominator. So now we have 1 minus uxv all over c squared minus this, which is ux minus v squared all over c squared, divided by 1 minus ux v all over c squared squared. Okay, so now let me just multiply out the top right there. Keep the bottom the same. We'll keep it down here as 1 minus ux v all over c squared squared. But the numerator, I get a 1. Then we get the cross term in there, which is minus 2 times the first times the second, minus 2 uxv all over c squared, plus the last term squared, plus ux squared v squared all over c to the fourth. Okay, and then we've got this term right here. The first term is minus ux squared over c squared, minus ux squared over c squared. Now the middle term is minus, but I get another minus, so it's a plus 2 times the first times the second. 2 uxv all over c squared. And then we get the last term squared. That's a plus, but that makes it a minus v squared over c squared. Okay, now I can see that 2 of these terms will cancel. That term cancels with that term. Okay. So this becomes, I guess we'll just come up to here. This becomes 1 minus ux squared. Well, okay, 1 minus, I think I'm going to put this term first. I'll put this one on the end. 1 minus ux squared over c squared. Minus v squared over c squared. Plus ux squared v squared over c to the fourth. Plus ux squared v squared all over c to the fourth. We still got that same denominator, 1 minus uxv over c squared squared. Okay, what I think I'm going to do is if I take these 2 terms right here and write those out, 1 minus v squared over c squared. And then what I think I'm going to do is out of these 2 terms, I'm going to factor out a ux squared over c squared. So we factor out I'm going to put parentheses, minus a ux squared all over c squared. That means that this term's left being 1. And then since I pulled out the minus, this becomes a minus. I pulled out the ux squared over c squared, so this is just 1 minus v squared over c squared. All over 1 minus uxv all over c squared squared. Okay, now I can factor these 2 out. So this is 1 minus v squared over c squared, 1 minus ux squared over c squared, divided by 1 minus ux v all over c squared squared. Okay, so that's everything in the green right there. Okay, now what I think I'm going to do is I'm going to now add this, say what is all of this inside the square root right there. Not the square root, just everything out in front. So that means that all of that right there is all of this minus this other term. So it's all of this, which is 1 minus v squared over c squared, 1 minus ux squared all over c squared, divided by 1 minus ux v all over c squared squared. And what are we going to do? We're going to subtract off 1 over c squared, and then we just have uy prime squared. Well, uy prime, which is right here, we're just going to square that. So that's uy squared times 1 minus v squared over c squared divided by 1 minus ux v all over c squared squared. Okay, just like I did before, I'm going to take this c squared and put it up above underneath here, and so that way I have all this common denominator right here. So that now, all on my denominator here, I have 1 minus ux v over c squared squared. And then in the numerator, I have 1 minus v squared over c squared okay, well, I guess I could have factored it out. It's in both terms here. So we'll just factor it out. So that term gets factored out. And so we're left with 1 minus ux squared over c squared, 1 minus ux squared over c squared minus y squared over c squared. So we got 1 minus ux squared over c squared minus uy squared over c squared. Okay, but ux squared and uy squared put together is just u squared. So this all comes down to be 1 minus v squared over c squared, 1 minus u squared over c squared, divided by 1 minus ux v over c squared squared. So that's everything in the blue. So now all we want to do is take the square root of it and flip it, because we want 1 over it. So now we can say 1 all over the square root 1 minus u prime squared over c squared is the square root of this, square root of it, and then flipped. So if we flip it and take the square root, this one isn't squared anymore, so that's just 1 minus ux v all over c squared. And then these two come to the bottom and they become the square root. So it's the square root of 1 minus v squared over c squared times the square root of 1 minus u squared over c squared. Okay, so at least we got that right there. So now we can go ahead and we can find out what is e prime in terms of e right here, because we know all this term down here. So we'll start out with e prime is equal to mc squared times all that 1 over the square root times this, which means all I have is this right here, which is 1 minus ux v all over c squared divided by the square root 1 minus v squared over c squared times the square root of 1 minus u squared over c squared. Okay, and I think I will write this in terms of two terms, this term and that term right there. So E prime is equal to, first thing I have is mc squared divided by these two terms. But mc squared, this right here, is just my E. Remember, E was mc squared all over the square root of 1 minus u squared over c squared. So all of that is just E. So we're just towing it by 1 divided by this term, divided by the square root 1 minus v squared over c squared. Then we have a minus. We have mc squared times this. Well, the c squared and the c squareds drop out, so we end up with an muxv, muxv divided by these two terms. The square root of 1 minus u squared over c squared, square root of 1 minus v squared over c squared. But this part right there, that's just my momentum in the x. You remember we said momentum in the x was mux over the square root of 1 minus u squared over c squared. So that's just p in the x. This in the red is just p in the x. So we can say that E prime is equal to E minus v times px, v px divided by the square root 1 minus v squared over c squared. So there is your energy, at least, total energy from one frame from Frank to Mary. If we were to do it the other way around, we already know the rule. Sorry, this is the unprime. And you switch primes with the unprimes and switch the sign of the v. We're not going to switch that sign since it's squared, but that one we will. So it's E prime plus VPX prime all over the square root of 1 minus v squared over c squared. So there is the transformation back the other way. Well, let's look at the transformation for px prime right here. Px prime is equal to m ux prime. Well, what was ux prime? Ux prime is right here. Ux minus v all over px prime is equal to all over the square root of 1 minus u prime. Well, we already know what all that is. All that term is right here. Okay. Better put that box around here. There is the denominator right there. So I just have to multiply it by this. 1 minus ux v all over c squared. And down below we have the square root of 1 minus, I'll put the u squared first, over c squared, the square root of 1 minus v squared over c squared. Okay, now, okay, so, just want to make sure we get, so we are at m ux prime, which is this. Wow, actually there's another term in there. Ux prime has this in the denominator, 1 minus uxv over c squared. And This had a numerator, 1 minus uxv over c squared. So there was a 1 minus uxv over c squared in the denominator here from the u. There's the u, and then the rest of this was that 1 over the square root. Okay, so that means that this term cancels with that term. Okay, and so now we have px prime is equal to. Now, you'll notice we got mux over this. Well, that's px. And we still have this in the denominator. Square root of 1 minus v squared over c squared. And then we get minus mv, I guess we'll just write it like this, minus mv all over the square root of 1 minus u squared over c squared, square root 1 minus v squared over c squared. Except I think what I'm going to do here is I'm going to put a c squared over a c squared. That way, here we have an mc squared all over the square root of 1 minus u squared over c squared. That's e. That's e. So this px prime would just be px minus. We've got an mc squared over that. That's e. And we've got a v over c squared. V over c squared. All divided by the square root of 1 minus v squared over c squared. And if we went back the other way, we would have px is equal to px prime plus v over c squared e prime divided by the square root 1 minus v squared over c squared. Okay, so there is your px and py. Sorry, px is both ways. We haven't done the py. That's the last one we need to do. So let's look at py prime. That's m uy prime. Uy prime is right here. So we got m uy prime, which is uy square root 1 minus v squared over c squared divided by 1 minus uxv, 1 minus uxv all over c squared. So that's just the numerator, so that's just this part. And then we still have this part down here, but 1 over that, we already had it, it's right here. So we just got to put that part in there. So we got a 1 minus uxv over c squared divided by the, where we put right here, 1 square root of 1 minus v squared over c squared, square root of 1 minus u squared over c squared. Well, let me see. This term cancels with that term. This term cancels with that term. And we're left with muy equals m. So we left up with py prime is equal to muy all over the square root of 1 minus u squared over c squared. Well, that's just py. So py prime is just py, and so I don't have to go back the other way right here. Boy, what do we have here? We have, you notice, see these equations right here, they look a lot like these equations right here. The z would be the same thing. Pz prime would be equal to pz. But you'll notice they all look the same right here. So just like this, the time was the fourth component of space. We could call this space-time right here. And we said there was a an invariant, this term was invariant to everyone measured c squared t squared minus x squared. Mary measured the same value when she did it in her frame, right here. You'll notice over here that energy looks like the fourth component of momentum. So energy is fourth component of momentum. Matter of fact, a lot of times, they say there's something called a four vector. Normally our vectors are 3 dimensions, x, y, and z. But a four vector would have an x, y, z, and t. But you could have the same thing with this. This is a part of a bigger four vector, which is px, py, pz, and energy. And when we say energy is conserved and momentum is conserved, it's really a big part of a much bigger conservation, which is that four vector, energy and momentum, is all conserved right here. So energy is, and so not only that, we can also say that E squared minus P squared C squared is going to equal E prime squared minus P prime squared C prime squared. Just like we had it before when we said x squared minus c squared t squared is equal to x prime squared minus c prime squared t prime squared right here. So you get this same sort of invariant. Everyone would agree on that. We know what that is because we do know that E squared from before, from right here, E squared minus P squared C squared is this. And everyone, Frank and Mary always agree on the mass and the speed of light. So that's an invariant. So now we have a second invariant. And so energy, x and t, acts just like momentum and energy right here. So even in quantum mechanics, the x and the p have some sort of a strange tie to them. Same with the time and the energy right here. There's some sort of they're kind of related in somehow right there. Okay, the reason why I wanted to go through these momentum transformations is because there's one other transformation I want to go through, and that is the force right here. How does the force in Frank's frame depend on the force in Mary's frame? Remember, the Galilean transformation said they were the same right here. Okay, but we'll see that maybe they're not. Okay.